Okay. Good afternoon, everyone. Long time no see after a week. And thank you for joining the class today. And thank you for most of you that already done the homework from the TA. And it turns out that professor also give the same practice, I think. It's from the book, the exercise 4.5, I believe. And I believe the quiz is already done, right? Last week. How's everybody's going? I hope the score is still as good as the previous quiz that you have. And I want to make sure, is it true that your midterm will be held on November 25th? I think. Is it true? If yes, I hope you guys all be ready. And today, I think I want to help the class as like last week, I think. So we can discuss some number that maybe you want to ask. So maybe let me share my screen for a moment. Yep. As always, welcome again for the new week. I hope you all healthy and ready for the winter. So welcome again to today's class. And please scan this QR code and let's see which number that maybe you want to discuss either from homework or from the practice that professor gave you. Oh, good, 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 good. Most of you pretty much confident with the curve sketching now, right? You guys are great. There's one question that want to be discussed, I think.好，嗯哼，嗯哼，
不用，我已经截图了。好，
great, 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 great.
麦克风开。
You all guys are really good. No problem whatsoever until now. Okay, okay. Is everybody already feel it? I think still no significant problem up to now. So I hope you guys can really be ready with the midterm later. Okay. But some of you guys still want to discuss some numbers. Number Okay, okay. Thank you, thank you. Hmm. Okay. Some of you guys still want to discuss some numbers. So maybe today we can discuss about it. It's two number two and number three from right? Ito? Yeah. And no problem for chapter 4 practice. Okay. So today we can discuss number 2 and number 3 from the TA homework. Let me prepare it first. Number 2 and number 3. Okay. Okay. Thank you for filling the questionnaire. Now let's see what we can do from number 14 and number 2 and number 3. Mm, okay. This is the question for number 2 and yeah, we do number 2 first. Use the guidelines of the section to sketch the curve. There will be, I think, 8 steps, right? And first of all, we can factorization first. So from this equation, we will get y equals to x plus 2, x minus 2. Okay, pretty easy. First, we need to determine the domain. So first, a wait. Hmm, hmm, Wait. Okay. Okay. First, we determine the domain. And as you already learned from, mm, I think, chapter 2, the limit one, and chapter 1, I believe. From this one, you already know the domain is around minus infinity and minus 2 from here, and minus 2, 2, and 2, infinity. It's quite big. Okay, pretty easy because you can make this denominator 0. So that's the domain. And for B, we determine the intercept. Since this equation is going like this, so there's no intercept at x. No intercept at x. But how about y? We can try to put 0 inside y intercept. And I believe you already studied this one in the class. Right? And if you want to know the intercept at y, you put x equal to 0. And you put here, you will get minus, I believe, minus 1 over 4. Okay, and see, we see is it symmetry or not, is it even or not. If you put like in chapter 2, I think, if you put x equals to minus, if it's the same like this, if you still remember, then f is even. So it means even. So it means this equation is symmetric at y-axis. You can try to put minus here. It will provide the same number. Okay. And the next one, we've tried to find the asymptote. Asymptotes. If you remember from the book, and I believe Professor Iman also have show it to you by put limit x of this equation. So it means x squared minus 4, is it equals to infinity? And if you put x to 2 minus over 1 x, x squared minus 4, it will be minus infinity, right? And if you got the same number with here, then you know that the asymptote will be in the plus minus, plus minus, which is vertical asymptote. And then you can check also the horizontal asymptote if limit x go to plus minus infinity, fx will be equal 0, so y will be 0. And this one will be the horizontal asymptote. Okay, and then you try to the e. You want to know the interval of increase and decrease. So it means the gradient, which is the first derivative, f x. So you derivative this one, you will get mm, minus x squared minus o 2 x. And then you try to put every number from the domain here. If x equals to this, x equal to this, x equal to this, how will this one behave? Is it uh, will be greater than 0 or lesser than 0? Greater than 0, it's increasing. If lesser than 0, it's decreasing. And if you put all the numbers from the domain, the function of s, will be increase on n minus 2 and to 0. You can try to put any number from this domain and this domain to here. It will be greater than 0. And f will decrease on 0, 2, and to infinity. Okay. The sixth one, we try to find the local maximum and minimum. So we put f equals to 0. And if you put the number inside, you will get minus 4 as the local maximum. And no local minimum inside. Okay. It's going up and up. Sorry. And then G, we want to find the concave and the points of inflection. So it means you put the second derivative, f. So you derive from this equation. I believe it will be long, but maybe I'll just put the summarized number here. So it will be minus 2, 3x squared minus 4, and x 2 minus 4. You can try to derive it by yourself and see if you will get the same result, or it will be just the same like 2, 3x squared plus 4. And it's the same. You will put any number in from the domain. So if the second derivative of fx lesser than 0, it will be concave downward. It will goes like this, I believe. True. And if fx second derivative, it will concave upward, which is like this. Okay, and from this you will get the number of this equation when you put x from the domain to the second derivative here, which number that lesser than 0. The function will be lesser than 0. It will be minus 2 and 2. And for greater than 0, it will be minus infinity, minus 2, and okay. So there you go. You already follow all the process. So now you can draw the figure, sketch the graph. So it will be something like this. From here, we know the asymptote, the vertical asymptote will be around plus 2 and minus 2. Let's say around here. Minus 2, plus 2. So there will be asymptote here. Okay. And we know the horizontal asymptote is on 0. What else data we have? We have there's intercept from V here. It's minus 1 over 4. So let's say it's somewhere around here. It's minus 1 over 4. Maybe put like this. 0 minus 1 over 4. And then we know from here, where is it? Oh, this. It will be concave downward in minus 2 and 2. Minus 2 and 2, so the figure will be something like this. and intercept around -4, and it will be concave down upwards at this number. So it will be like, sorry for my bad drawing, but I hope you understand. So it's pretty much like this. So this is the whole process for number 2. Is there any question maybe before I continue to number 3? It's quite long way. Any question? Is that everything okay for number 2? So every process is important, but sometimes just some part of the process can make sure you can draw from this figure. Like when you know the asymptote and you already know how the figure concave from G, you can draw this kind of figure. Okay, if there's no question, I think we can continue to number 3. So this is the question. Use the guidelines, the same process as before. Y equals to e to power of x over x squared. We don't need to factorization because it's already the equation, right? So at first, we determine the domain. Pretty easy because they have the numerator here. It cannot be 0. So the domain will be minus 0 and 0. This is the domain. And there will be no intercept since we have the E here. So no intercept. Either at x or y. And there will be also no symmetry. Because if you put number here, the E, f minus x is not equal to fx. And find the asymptote. First, try to go to minus infinity of this function x. You will get 0. So y will be 0. Which is y0 is the horizontal asymptote. and x approaching 0 of this one. If you put the number inside, you will get infinity. So x will equal to 0, which is the vertical asymptote. So the vertical asymptote will be at x equals 0, and the horizontal asymptote will be equal y equals 0 as the horizontal asymptote. Okay, so the asymptote will be happen in the middle, and then we find the interval of increase and decreasing. Again, don't forget, if you heard the increasing and decreasing, it means the first derivative. So it will goes like this: f x, the first derivative of this one, you will get e x x minus 2 and over x 3. And when this one is increasing and when this one is decreasing, if you put any number from the domain here, you will get increasing at minus infinity 0 and 2. And at this one, you will get 0 and 2. Then next one, find the local maximum and minimum. So you put the changing point here. So try to, it will be equals to e, sorry, wait, sorry. So, okay, 2 equals to a square 4. If you put the number, it will be around 1.85. So this is the local minimum. And there will be no local max. Then find the concave. So you put the second derivative. this one. So you derive from the e here, and you derive again. You will get e x squared minus 4x plus 6 x4 greater than 0. If it's greater than 0, since there's no local max, so everything must be concave upwards, just like this. And you can try. If you put any number of x, it will be greater than 0. Okay? And so, from here, you can draw the figure. Since there's no negative, maybe the figure will be something like this. So, y and x will be the asymptote. And no intercept. So there's no line that across the y or x. No symmetry. Y and x is the horizontal and vertical asymptote. And if you put any number, it will go concave upward from minus infinity to 0 and 2 to this. So it will be like this. And let's see if you have the local minimum here. So the local minimum around x equals 2 and y equals 1 over 8, 5. So it will be something around here. 1, 2. Let's say somewhere around here. Just like this. Okay. So there's for number 3. Basically, I give you how the answer will be. But after doing it for number 3, doing it the asymptote to x. It's okay. You can try to put the number there, but you get still the same result, which is the horizontal asymptote and the vertical asymptote equals to 0. But you can try the process from the book here. X plus infinity. This one. For the asymptotes thing, you can try all of this function and see what's the result. But what I show you in the in here, actually it's already the answer. But you can try, and you will still get the same result, which is a asymptote of either horizontal or vertical will be at 0. Okay. Any question, maybe? Y equals to x3, x1 is x0 critical number. Can I know which number? Number 3? Is it number 3? X minus 3. Can I know which number is this? Is it number 3? Chiu, I believe it's Chiu. No. Number 2? Y x minus 3x x. Hmm? Which number? I'm sorry. It is the oh. Okay, okay, okay. Let's see. Is it goes like this? Y equals to x minus 3. Is it like this? And is x equal 0 is critical number. Is this the question? Yes. Oh. Okay. That's it. Anyone want to answer this question? Anyone? Y equals to x minus 3 as array is x 0 is critical number. So if you put x, you mean critical number is the maximum or minimum value, right? Anyone? May I know where the teachers give you the example? Is it from the book or just in the class? In the video. Ah, okay, 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 okay. Okay, okay, okay. Anyone want to try to answer this one? On Google Classroom. Oh, okay, okay, okay. I'm really sorry. I haven't seen the video yet. By the way, first of all, maybe while waiting, you guys can feel the attendance here. So it's quite different from what that I give you before. The before it's not the attendance; it's just the question that maybe you want to discuss in today's class. But now it's the attendance. So please fill the attendance now. And if anyone want to try to answer what you and ask, is 0 is critical number? First of all, Chio, I'm really sorry. Maybe I'm not quite sure I understand your question, but let's say I will see the video today and maybe I'll give you the answer by the model. Is it okay? I think the time is quite okay, okay, okay. But I'll see the video today. And if there's something that maybe I don't understand, I also will ask professor and show the answer in the model. So just check out the model. I'm sorry and thank you for the understanding. Okay, please fill the attendance first. I'm sorry if today's my voice quite weak. I'm not really feel good, but thank God that we still can do this class. Okay. Don't forget to fill the attendance and thank you. I hope you have no problem. And maybe for next few days, I'll give you some question from optimization, which is number 4, if you remember from the homework that we've give. And I hope it can make you learn faster and be prepared for the midterm next week. Because I see most of you have no problem with the curve sketching. Okay, thank you very much. I believe it's almost 1 minute. Thank you very much for joining the class. If you already filled the attendance, you can leave the class. Don't forget. It's still four that 4 people that fill the attendance. And see you again next week. Thank you very much. Thank you, Rian. Thank you, Evando. Thank you, everyone. Thank you, everyone. And I promise I will, Gio, I will give you the answer. Just wait, just wait. Thank you, thank you, thank you.